Hello, everybody. Welcome to the Space System Modularity webinar. Today, we're here to talk about how space systems is changing and how that would bring new opportunities for satellite hardware suppliers. Thank you for attending our webinar. We have three senior space system experts to discuss modularity, and we hope you enjoy and benefit from this activity. We will have a Q&A session in the end of the 50 minutes panel. You're welcome to ask all the questions in the Q&A button below at the Zoom bar. We will try to answer as much questions as possible. Those questions will be marked and forwarded to us so we can answer them as much as possible. And the rest of the questions we will try to answer in a later date. Just to note you that this webinar is recorded, so you'll be able to rewatch it later on and also to have your questions recorded. So let's talk a bit about space system modularity. So it's always been in kind of the back of the mind of a lot of people in the space industry. And it's been around for a few decades. And unfortunately, a lot of times it's been ahead of its times. It had a lot of different opportunities or different kind of projects like Savoir in Europe, Sumo and Monarch in the US that aim to standardize how we develop space hardware, connect them and deploy software. But mostly these kind of projects staggered because of the lack of immediate need by the stakeholders like the governments and space agencies and commercial entities. Lately, we see a lot of new technologies that are emerging that requires more powerful systems. Technologies such as artificial intelligence for image processing, software-defined radio, and laser communication. But the turnaround time for these technologies is, but the current turnaround time for new technologies in our industry is about 5 years, which means that the industry is always lagging behind. New technologies might be the driver for bigger players, but also medium players have a bigger focus on driving down the cost and the lead time to be more competitive. Serial productions like OneWeb and SpaceX and BlackSky drives down the cost and create more and more hardware with heritage that is available off the shelf. Unfortunately, we see that we're not quite there yet on modularity. Many ventures have gone bankrupt in the last few years, since they ran out of money and couldn't reach the goals to create revenues and to create enough revenues to raise more capital. Now, space modularity is coming to be the new glue between new technologies, existing commercial off-the-shelf heritage subsystems, and the needs of new space companies. Modularity is no longer a buzzword. With recent selections of modularity in Europe and in the US, such as Space 3PX and Serial CPCI Space, there are plans by the space agencies to already use those standards to reduce the cost and time during all the phases of the programs. So suppliers are starting to ask, what do we need to do to prepare for this concept? And how do we make our subsystems digitally and physically compatible to make sure that we can benefit from large quantity orders and better profit margins? Today, we're here to try to answer those questions for you. Hi, my name is Ran Kedar, and I'm the CEO and co-founder of Space Product Innovation, or in short, SPIN. I'm about 10 years into the industry with experience in the Israeli space industry and the European Space Agency. Our company develops a plug-and-play adapter that makes hardware and software components that integrate existing space components to modular systems without the need for customization, software changes, or any manual intervention. I'm really happy to host today the webinar, and joining us today are John, Andrew, and Rodrigo. So let's meet our panelists. John Springmann.
Hey everyone, my name is John Springmann. My background is in aerospace engineering and small satellite design. I've been working on small sat design for about 10 years, kind of CubeSats up through ESPA class spacecraft, and all phases of design from kind of concept through build, integration, launch, and operations. Pleased to be one of the panelists today.
Thank you, John. Andrew?
Hi, everybody. My name is Andrew Chereck. I've been in the aerospace industry for about 15 years, about 11 years at Lockheed Martin, and the last year at JPL NASA. Got degrees in physics, aerospace, engineering, and system architecture. I've worked large flagship missions from human spaceflight to geostationary orbit satellites, everything that's, many thousands of kilograms as opposed to several hundred. Yeah, just happy to be here today and share my experience.
Thank you, Andrew. And last but not least, Rodrigo.
Hi, everyone. My name is Rodrigo Diez. My background is in electrical engineering. I spent 15 years designing subsystems, electronics, and algorithms for radars and satellites. I had the chance to work with both COT technology in CubeSats and also rad-hard technology in big satellites. I have a master's degree in system design and management from MIT. And last year, I decided to put my PhD in aerospace engineering, also from MIT, on hold to focus on Novo Space, a company developing high-performance electronics for new space applications, for which I'm the co-founder and CEO. Thank you very much for the invitation.
Thank you, Rodrigo. So let's just dive in. So satellites are now being launched in thousands per year, thanks to Constellation. John, is space hardware becoming a commodity?
Yeah, that's a great question. So from my perspective is that no, space hardware is not a commodity yet, but I do think we're getting there. So most of my recent experience has been kind of in the small sat, microsatellite class, as opposed to CubeSats. So we may be a little closer in the CubeSat world, but I just haven't seen high quantities for many components or subsystems. And when you go through a procurement, it's always they're building to order. It's RFQ, RFP process. There's no indications of really the high volume commodity production or high volume production that I think is indicative of commodities. I think that a lot of the mega constellations are helping with that, but a lot of those are vertically integrated and I think not really helping the supply chain that much. So for example, SpaceX's satellites are very vertically integrated, and the other mega constellation providers, some of them are buying parts, but again, they're kind of customized a bit for those mega constellations. So I don't think we've seen that trickle out yet into the supply chain in general. So from my perspective, yeah, no, most space hardware kind of is not commoditized yet, but I do think with the larger volume of satellites being launched and being launched across many more companies and many more providers, we're certainly on a path to get more commodity-like.
Thank you, John. That really is a positive outlook on the future. And Rodrigo, how does that outlook affect your business, and what is your view on commoditizing hardware?
Well, very similar to what John said. I believe there is some level of commoditization only in CubeSats with the PC104 standard. I'm talking about these 100 by 100 millimeters electronic boards, but there is not too much going on with bigger satellites. And it's funny because it's when we need it the most, because we want to have very reliable products. We are concerned about space heritage. So we need it there, and it's happening in the PC industry. You can connect components from different vendors and everything works pretty nicely. It's somehow happening in the defense industry with the old compact PCI, BME, and today with BPX and OpenBPX. But for satellites, especially for satellites bigger than CubeSats, it's not. And I believe that it's going to happen soon with electronic boards. I'm talking about CPUs, mass memories, signal processors. But with regard to subsystems, then the story is a little bit different because you always need some level of tailoring. Maybe with the bus subsystems could happen, but again, there are many satellite integrators putting different functionalities in the same box, so every subsystem is different. And I believe that the best path moving forward is achieving that ad hoc functionality through the combination of different off-the-shelf electronic boards, like the ones I mentioned before.
Thank you, Rodrigo. And Andrew, do you think that using kind of the technology that Rodrigo described of having commoditized boards, is it something that will come out of these multiple thousands of satellites are being launched? Do you think that JPL will once have this kind of opportunity to buy commoditized space hardware?
Yeah, that's an interesting question. I think to go back to what John said, some of these large constellations are vertically integrated, so they're developing their own hardware in-house, and that's not really, they're not supplying it outside of their own businesses. So for something to truly become a commodity, it's got to be something that everybody wants, everybody can get their hands on, and is widely available. You know, I know, at least with my experience at Lockheed Martin, that was always a goal, that we were trying to build boxes that had common cards and common designs that we could share across programs and across spacecraft, and apply to different missions. And that is an end goal, and it is something that the industry is working towards. You know, whether they get there in a hurry or not is a different story, but it is something that companies are working at. JPL is a little bit more unique in that, as an arm of NASA, it tends to just do whatever it needs to do to get the mission done. That being said, they do compete for projects, and so they are aware of cost on some level, and they will attempt to design boards that they can carry forward from mission to mission to mission. But as far as providing those designs outwards, we're still not there yet, as far as I know.
Well, that's what we're looking at the future here.
Mm-hmm.
Thank you, Andrew. So let's discuss a bit about the modularity. So modularity itself is kind of a concept of bringing more opportunities, especially when we're talking about how we're going to assemble satellites in different configuration to have much lower cost and much lower lead time in getting all these different components, which hopefully get us to that place where we talked about commoditization. So what do you think that is will bring to the supply chain in terms of the procurement time and entering new market? And I guess I'll ask Rodrigo first, because kind of it's his business line of entering the supply chain faster and better.
Yeah, totally. Well, think about the space industry 10 years ago and the space industry today. I met my co-founder Facundo 10 years ago. We were developing the main computer and the mass memory for the synthetic aperture radar that was the main payload in a big mission, in the Southcom mission. I'm talking about two boxes like this with a lot of electronic boards with the old VME using rad-hard components. The satellite cost like more than $200 million. A lot of people involved in the project. So when you have a project like that, your main concern is reliability, right? Because you don't want the system to fail. A few years later, we were talking with the guys behind ISI, and they are planning to launch a constellation of satellites. I'm not saying that is the same performance, the same requirements as the one I mentioned before, but it's the same type of instrument. But they are going to launch like many satellites. The size of the satellite is going to be much smaller than the one I mentioned before. The cost is going to be for sure less than $200 million per satellite. So if one satellite fails, it's not the end of the world. So reliability is important, but it's not the only important metric. For example, today you have Capella and others doing similar things, planning to launch constellation of satellites. So now they are competing. And when you are competing, when you are in a market, the time to market or the time to orbit is important, which can be decomposing lead time and integration time. And also cost is important, also performance, because you want to deliver a better product than your competitors. And I'm not talking about modularity, but modularity is what enables that, is the way you can address all these pain points in the new space industry. So if you have modular electronics, you can have stock. so you can reduce the lead time, you can reuse, so you can increase the space heritage, and then the reliability. You can reduce the fabrication cost, the R&D can be distributed among many missions, many satellites, so it's there. And Andrew mentioned just some minutes ago about this modularity in some companies, and we've seen that happening in different companies, but it's important to add that you also need open standards, because you can talk with several companies that they are going to tell you, hey, we have modular components, but they are only compatible with other components they develop. And when you talk with NASA, Air Force, Space Force, commercial space, they are all looking for the same solution, something that is compatible with other solutions in the market. They don't want to be vendor locked anymore. So it's both modularity and open standards.
Thanks, Rodrigo. So John, do you agree with that? Do you think, as somebody that's designing satellites for constellation, do you think modularity will change your business?
I think potentially, yeah. To me, like what modularity enables is those subsystems and components and the suppliers of them to really focus, I think, on the performance of the system and the reliability, and kind of driving the cost down and the performance up. I think today when I buy satellite components, if there's a lot of non-recurring engineering involved, a lot of it is on the interfaces actually, both on the hardware and software. So, you know, whatever it is, whether it's a transceiver or a flight computer, you know, the core of it is kind of largely changing the same. And if you're paying for that component, a lot of it, like I said, is those non-recurring costs that don't really impact, I'd say, the core performance and the core capability of it. So I think with modularity, hopefully the supply chain can focus more on performance and reliability and radiation tolerance and things like that. I think that would be really helpful for the industry overall.
So you think in terms of having space heritage completely flight proven with long-term results will bring you to be able to buy components faster and integrate satellites faster? Is that the conclusion, or am I in a different direction?
Well, I think that's, I mean, the long lead time now isn't driven by a lack of heritage, right? It's driven by lack of high quantities. So the suppliers have no reason to kind of roll up start high volume production, right? So a lot of parts, especially again bigger than a CubeSat specifically, I think, are all made to order, or if they stock parts, they're in low quantities. And suppliers that I've seen certainly aren't running environmental test campaigns on the parts, you know, ahead of time. So even if components are on the shelf today, if you buy it and say that it's modular enough to fit into your interfaces, it's still going to take time to usually run an environmental test campaign and acceptance campaign to get it to the level that, as an integrator, you want it to be to take it in and run it on your assembly line. So I think modularity can definitely help with that. It's not the only answer. There's a lot of other, I think, supply chain issues that need to be solved, but I think it's really could be a key enabler, if that makes sense.
Yeah, thanks, John. Andrew, looking at the side of the big manufacturers in your past and right now in JPL, what do you think that is that also opportunity to bring new components if there is modularity when there's no really you know, major benefits for companies that don't make multiple satellites per month?
Yeah, so coming from the perspective of companies that are making, you know, large platforms that they're launching infrequently, the focus they tend to have is going to be risk versus opportunity. And a lot of the way they set up their business is risk avoidance. They're looking for things they know work, and they don't want to spend a lot of time bringing new stuff in that they don't know very well. The one thing modularity allows for is kind of a plug and play. It gives them opportunities to swap out a sensor if there's a competitor making a sensor that can deliver that on time or on the schedule that they need. It gives them an opportunity to maybe go with a slightly out of date payload for a mission that gives them most of the capability that they want, but not all of the capability. But it's something they know works while they develop the new thing. Because everything that, you know, every time you're doing new development, you know, there's the test campaign, but there's also just a lot of room for design errors, and you don't uncover some of those design errors until late in the flow. So having the opportunity to off-ramp a new design into an old design, I think that's one of the biggest things that modularity can offer. Along with just, you know, making testing and integration easier, you know, particularly if there's things that just you plug it in and it works, the interfaces are defined, that just removes, you know, days or weeks of time actually spent putting something together. So
again, we need open standards.
Yes, I agree. Very much.
I guess I need to add to that. So I completely agree. We need open standards, but we also need to agree on a set of standards. So there's so many standards there, both on data exchange, on type of hardware you use, and the interface connection, that if we continue to use all these standards, we're never going to go anywhere. And this is a thing where we're working on it, but we're just not there yet to enable full modularity.
Yeah, right. And if I can interrupt for a minute, sorry. At the physical layer where I work a lot, I do a lot of electrical cabling, and even just what connector you use to connect to a box. Data bus can be well defined, but if you went with this commercial company versus this commercial company for their high-speed interface, they're different and they're incompatible, and they each have their pros and cons. Yeah, just moving away from software and do the bits get from here to there.
And it's down to you to solve all these issues.
Yep.
Yeah, just a quick note on standards. I mean, there's plenty out there, even in the CubeSat and SmallSat world. The problem is that no one's incented to actually use them, right? So you have these little pockets, little groups of people that use different standards, right? For example, you know, you see some use of like the CubeSat space protocol, right? And within the European CubeSat vendors, but you don't see any of that in the US vendors. Some folks use nanosat protocol, you know, et cetera. There's the whole AFRL SPA standard. There's tons of standards out there. I think the question is, how do you incent the integrators to actually use them and the vendors to use them all together? Because I think the problem today is, as soon as you do build a number of satellites in any very modest quantity, you know, even a few or 5, it's then worth it to use whatever standard you want to kind of just minimize your own costs and your own production time. So there's very little incentives, I think, today for the industry overall to agree on some common standards.
Well,
I don't know how to solve it, but that's the problem that I see.
Sorry, I'm gonna jump in this question. We had many conversations with different new space companies, and the problem doesn't finish when they are done with the design, because they are competing with other companies. So then they need to refresh the technology every couple of years. And with many companies, even though they had finished the design, they were interested in talking with us because the business was, I don't know, having synthetic aperture radar products for customers, and they were not into the business of this designing electronic boards or things like that, or whatever it is, right? So I agree with you that it makes sense for low quantities, but I would say that for medium quantities, probably it also makes sense. Yeah, we've been having a lot of conversation with different people regarding that. And after some time, they realize that they are spending a lot of their R&D in the electronics that is not their business. So yeah.
That's a great point.
I agree that it makes sense for. Yeah, I agree it makes sense for any number of quantities. It's just how do you get people to agree? I think it kind of depends a bit on quantities to get it started. Yeah.
So this brings us actually to the next topic, serial assembly. So it's a great segue to a point where we know that there already are factories that exist, for example, OneWeb in Florida and the one for SpaceX for Starlink, that do serial assembly. So the meaning multiple satellites go on a production line and each part is added or assembled in order to create a production of few satellites even per day. But this serial assembly is usually not modular. So that means that there's any changes during the process, you either have to stop the whole production line and start doing the changes and affecting all the different kind of components and rework the existing satellites. And of course, have to redo the verification, which for a satellite system integrator is very important and expensive process. So there are a lot of disadvantages and advantages of having serial production currently, even without modularity. So this is where I actually wanted to ask John, what do you think about current situation about having serial production in these kind of low quantities below 1,000 per month? Do you think those make sense? And do you think there are advantages for those?
Yeah, I think it could definitely make sense. I think it's always a trade on, what you're building and the maturity of what you're building. So, for example, I was the chief engineer at BlockSky for some time, and BlockSky has set up through their subsidiary LeoStella serial production, right? So, but their quantities are not anywhere near thousands, right? They're currently launching, kind of targeting low tens of satellites. So I think it can definitely make sense. I mean, serial production has been used in other industries for decades. I think it comes down to, there are a few of the key things that come into it are the commonality of the satellite, right? If you're stamping out a bunch of the same things, then of course it makes more sense. Or if things are custom, where are they customized, right? You could have a serial production bus, serial bus production, right? And then have some custom payload interfacing, for example. I think the other thing is really the maturity of the design. I mean, the problems you mentioned, Ran, about if you have to pull something off the production line or if it doesn't work, you have to requalify it. To me, that's indicative of it probably not being ready for serial production. I mean, you need to have your design very well established and have it work. And until you get to that point, I think it's tough to serialize the whole thing. Again, you can serialize parts of it. And I think the other thing is a bit satellite size and just logistics and kind of the GSE involved, right? It's a lot easier to kind of move a CubeSat down the assembly line than it is, moving like a 1,000-kilogram satellite down an assembly line is probably never practical, as opposed to bringing different sets of GSE to it. So I don't know that there's a clear answer. I think there are certainly cases where serial assembly is really advantageous, but it can take some time for companies to get there in terms of what they're producing.
Thanks, John. Yeah, I think that's a great point, and I think serial production is probably currently a case-by-case basis, according to how much the satellite is ready and if there's immediate need to upgrade. Of course, the problem is that if you're in the low tens, once you finish your production, you usually have a stall of the current constellation for a few years, then you're looking for other customers. And this is where a lot of companies are looking for using their serial production lines for other parts or other kind of missions. So, Andrew, what would you think about if there was some sort of a serial assembly in one of the big manufacturers? Do you think they will be able to take that advantage?
Yeah, that's a good question. So, so far what we've seen with serial manufacturing has been low Earth orbit satellites, as far as I know. There's been some serial assembly of larger, like geostationary platforms. I think before we got into the current era, the last time we saw kind of high production was Iridium, and they might have been doing like 6 a month or something like that, for a total build of like 70 satellites. And that was big for when they were doing that. Now we're talking, I think SpaceX is doing 120 a month is what they're putting out for Starlink. Going back to what John said, and a little bit back to tying to the modularity, is I think what the large spacecraft manufacturers have been focusing on is sort of serial bus and commoditizing the bus as opposed to commoditizing the lower level components. And so what they want to be able to do is take their bus and sell it around to other customers and just pop on payloads as they go. and they haven't drilled down to the level of, yeah, can we commoditize the various cards and boards and computers and sensors and all these other stuff, because I think where they think they make their money is on selling a bus, not selling the integration of all of the various components that they can put together. And that dynamic is probably going to need to change if they really want to get into manufacturing high volumes of spacecraft, particularly things that are over 500 kilograms. Just having kind of been through the flow of how long it takes to build some of these larger satellites. I mean, you're talking years between sourcing the components and then assembling them and then putting them through a thermal vac chamber and a vibe and just running all the various software tests at once you build up the subsystem and you build up the system, and just all of that testing is it takes a very long time. But these platforms are designed for missions that have multiple uses, multiple bands, multiple sensors. We're not talking, a low Earth orbit satellite that has just a radar or just an optical payload or just one mission. Those can go, much quicker. The stuff I've worked on has been, a lot more complex. Anyways, I'm not sure I totally answered your question, but the goal of the serial assembly is really to reduce cost over time. Build multiple things, be able to source components from suppliers and get, buy 10 of something or 100 of something instead of just one. And then you can amortize the costs across those multiple buys. That tends to be the biggest thing. And right now, a lot of these, the Lockheeds and Boeings and Northrop Grumman's, their platforms are still set up for, we sell one or two of these. We're not in the business of building, tens or hundreds. But also their use cases don't always involve them needing to build these large numbers. One geostationary satellite has the coverage of many low Earth orbit satellites. There's, the trades for doing one versus the other, obviously, and there are reasons to go low Earth orbit, but that tends to be where their bread and butter tends to be bigger platforms at this point for these established companies. New Space, it's different. So.
Yeah. No, I think you covered most of it. And I think this is the point where a lot of companies are now trying to recuperate most of their initial investment in the serial production line by selling off the bus. You can look at the OneWeb financials and you see hundreds of millions, around $1 billion invested before the first satellite even came into the manufacturing. Part of it was just to set up the production line, but a lot of it went to different suppliers in order to kind of make sure that their parts matches the bus and their design that they wanted. So those are sinking costs that they need to recover. But of course, this limits their opportunities because they're now limited with these suppliers. So if this one of these suppliers go bankrupt or something is missing, then they need to do an additional initial investment. So yeah, there's always a pros and cons in order to get to that level. I want to remind everybody that if you have any questions and answers, please use the Q&A button in order to raise the questions and we will answer it later in the panel. So let's go on a bit about how the suppliers are having trying to enter the market. So now there usually is two approaches. Either you are a qualified supplier for a large manufacturer, like Boeing or Lockheed Martin, where you have your baseline and you're selling your parts, or if you're going into the new space constellation and you're talking about winning that contract, winning some upfront money in order to customize your component, in order to fit that, and there you're locked in, and then you're just running into trying to find the next contract. So each time is the next contract, and there's a lot of barriers into those different parts. So Andrew, from your experience, how big is that barrier to market for new suppliers? How many times have you seen in your career new suppliers enter Lockheed Martin?
Not often, and primarily the only time we get new suppliers is when we face a new requirement that we haven't solved before. When there's a new challenge of it needs to meet this cost threshold or this performance threshold that we haven't seen before, and it's like, okay, our existing suppliers, maybe they can, maybe they can't do it, and then we start looking out. having been in some of the early meetings on some vehicles as far as like architecture and how that goes, you find that architects of like a space system will go, all right, what have we used before? Who do we know? Let's okay, we've used, you know, Honeywell, we've used BAE, we've used Seeker, we've used, okay, let's maybe even if it's a new electronics box, yeah, we know these guys, we know how they're, we have business with them as far as, you know, we know how they perform, we know they can deliver, we know they'll bring up issues, we know they're local in town is sometimes one of those things, so we can just pop over there. You know, there's a lot of that stuff that comes up that's just kind of the simple, like, these are just the people we work with, so these are the people we continue to work with. And so getting new suppliers in, it's always a question of, you know, I'll come back to risk again. It's like, this new company, we don't know, maybe they have built hardware, but it's hardware for ground missions only, not space missions. We don't know whether they can perform and deliver on the cost that they say, or on the schedule that they say. And so there tends to just be that mental barrier for a lot of companies. I mean, setting aside all of the, you know, cost or difficulties or anything like that, just a mental barrier for the people involved in designing these spacecraft, saying, you know, what do I know works? Who do I know that I can work with? And what are the established players? That tends to be one of the bigger things. Just setting all that aside. I mean, and then also there's just, okay, you're a new startup company, getting your hardware qualified for space environments. I mean, there's only so many facilities that you can go to. They're often expensive. You know, you got to go put everything through your thermal, your radiation, your shake and vibe, and maybe pyrotechnic testing, all kinds of just testing. You've designed a board and you still have to take it through a whole bunch of things, and not to mention, you know, just the materials you use in these environments is different than things you might use on a terrestrial, you know, environment. So there's just, I mean, you could go down the list of technical barriers, but again, one of the bigger things is just the colloquial nature of some of these old space companies. They've got established supply chains and established ways of doing business. So
Yeah, it sounds like the process hasn't changed in the last 30 years. And
no.
But I'm guessing now, talking to John, do you think those barriers to entry as hard as in the small sat new space market?
I don't think they're quite as hard, but I mean, I agree with kind of all of Andrew's points. I think small sat integrators are becoming smarter and more focused on reliability. So I'd actually argue that the barriers are probably becoming more difficult again. There is I think heritage is of course important, but if you put kind of heritage aside, there's a lot of rigorous analysis and testing that can be done. You know, like reliability analysis and radiation testing, I think, are two things that are a bit lacking in the small sat LEO world. And I think the industry and integrators are getting a bit smarter and actually kind of looking for that. So the barrier in some ways I think might be getting a bit higher, because there is a better focus on reliability, which I think is great, like really good for the industry. But yeah, there is the few of the technical factors, like I said, kind of everything that Andrew mentioned, and then I agree there's a big programmatic evaluation as well, particularly for these small constellation providers. Kind of the program management interface, you know, what's the ability of the company to deliver on the dates? You know, what happens if they can't? You know, what's the stability of the supplier? What if they just decide to, you know, stop making the parts?
Yeah.
With the COTS components too, there's a lot of obsolescence concerns, and particularly going back to radiation, right? Lot testing, what happens if an IC changes? There's some tough supply chain issues that I think are unique to the space industry.
Do you think that this is because currently the lead time is still very long until you see the first satellite launch and already in orbit, or is it more because you need to think about long-term activity of the satellite, since most of the constellation planners tend to plan for 5 to 7 years lifetime and not 1 to 2 years lifetime?
I do think there's a drive to longer mission life. in low Earth orbit, or for small satellites. You know, because when CubeSat started, you know, it was maybe a few years typically. So the issue is, I think for new suppliers that are coming from outside of the space industry in particular, there's a lack of familiarity with kind of the harshness of the environment and how you actually convince yourself that it's going to operate. I mean, regardless of really the lifetime, if you're designing it 1 year versus designing it 10 years, okay, how do you convince yourself and convince your customer that it's going to last that long?
So that's an excellent question. So Rodrigo, how do you convince your customer that your product is going to last that long?
Testing. We don't see flying hardware as a very, let's say, convincing argument. We believe that you need to test a lot. And in fact, we are about to start our radiation test campaign, our environmental test campaign soon. So yeah, testing.
And
sorry, let me add something. There is a lot you can do before, right? You can select components with space heritage. You can design error detection and correction codes. You can design shielding to reduce the total ionizing dose. You can use modular level redundancy. There are many, many things you do, but at components level, you can either have the information that will survive or you need to test.
yeah. And this is actually very interesting because if you look at currently procuring new components, either in new space or traditional market, it's not just a way of just marking the checklist, like having the tests, which are very hard, and it's impressive that you're currently doing that and doing all the process. But it's also about being right on the right time, planning to the right mission, being on the right lead time in order to provide to your customer. And then, of course, providing all the analysis in order to make sure you're compatible to that satellite platform or to the other existing components. So it has a lot of effect, but I'm wondering, does procurement of components also affect processes such as integration? Does knowing ahead of time when does the procurement ends and where do you get the parts affect the process of assembling it physically to the satellite? And maybe Andrew can enlighten us a bit about that.
Yeah, and I'll try to limit this just to the scope of the hardware that I've actually designed and built, but procuring parts is a question. I mean, yeah, we've got to try and get our design nailed down enough that we can order things a year ahead of when we actually need them, because it's going to take that long to get something in. And, you know, I've had experience of, we had, you know, design features that we either forgot to have in our design or that we added in and didn't need, but it's part of what the design is now, because we had to nail things down so far ahead of time. Yeah, just getting piece parts, even just getting, if your supplier sets up a new manufacturing line that they haven't tested before. I mean, I had experience with buying connectors from a qualified supplier, and they had built hundreds and hundreds of thousands of connectors, but they started up a new assembly line and they found out some guy was squishing the molds or something at some point in the process, and we got bogus connectors from a supplier we trust. So issues can sneak in the supply chain at all levels, even from people, even from stuff you've been buying from suppliers you've been buying from. And it's always a difficulty at the higher levels of integration to trust what you're receiving. And it's one reason that we do so much testing at the integration level, is just verifying everything we've received along the way is actually what we think it is, because so many times it isn't. So, and that adds to a lot of the costs and a lot of the barriers to entry of various suppliers. So.
I guess that's a bit about the luxury of bigger manufacturers like Lockheed Martin, when they can pass some of these costs. But when you're more competitive and when you're looking at John and producing that, what is the plan B when you're having procurement already done and you're going into integration and you find out that something is not compatible? how does that procurement affect? What is your
Well, if you find something that's not compatible when you're going into integration, I think you've missed a few steps before integration. So I mean, the problems, like, yeah, I mean, joking aside, like the compatibility needs to be vetted, you know, much earlier in the program. And the typical problems that you would see in integration are hopefully not interface problems. You know, maybe some kind of behavioral or kind of system to system interaction. You know, there's all kinds of edge cases and optimal cases. So you need to make sure when you're testing kind of at the component or the subsystem level before you integrate that you kind of cover all that. I think a couple of quick comments on back to serial production a little bit on supply chain. You know, when you are doing serial production, supply chain management, I think, is huge. And there's, even if you're maybe saving some, maybe the problem becomes less technical in certain regards, if the design is done and you're serially producing it, but there's a much bigger program management and supply chain management problem. You know, when are your parts coming in? How many extra are you keeping on the shelf, right? If you're doing serial assembly, something doesn't work functionally, you swap it out. You know, are you sparing? Is the supplier sparing? Who's doing the unit level environmental acceptance testing? You know, if you're doing it at the unit level, if you want the supplier to stock extra parts or to spare parts, you know, are you going to pay them to do that? Because again, there's very little incentive for them to do that on their own. So there's some significant costs actually associated, I think, with kind of proper serial production, even if your satellite design is supposedly, you know, complete and rigid at a certain point.
Yeah, I guess that is one of the challenges that is not just part of being a system engineer, but being actually kind of the administrator to make sure that everything is all on time and all on place.
Yep.
Maybe we need.
Yeah, Yeah, let's. I mean, I don't want to harp on it too much, but so there is a program management aspect of it to it and an administrative portion to it. But there is real issues in tracking what your suppliers are doing with their parts. You know, what if components are changed? What if, you know, a microprocessor on a part comes from a different batch that hasn't been radiation tested? You know, are you comfortable with that? Yeah. And if you're running a rigorous program, you care about all that. A lot of that stuff isn't happening yet, kind of in the small sat world, but maybe that's another, going back to the barrier to entry's question, there's a lot of aspects.
Yeah, I think those are excellent points, and I hate to say that word, but maybe that's requiring another standard. Well, standard of supply chain for space. So let's move on a bit. So we see this is also as an opportunity for a lot more new technologies to enter the market. We know that there's already are processes to accept high-speed bus connections and smart sensors. We know that Novo Space is really working on the next generation for a modular system and creating new technology. So Rodrigo, what do you think is the next thing in our market, in our industry for space technologies?
Well, I can tell you about a couple of different technologies I've been personally involved, not so somehow related to Novo, but for sure there are many more. The first one is autonomy. And the reason is that the number of assets in space and the complexity of each satellite is growing very fast, and the number of people in the space industry and the number of operators in the ground stations is not. So we need systems to make their own decisions. We need some way to prevent and to detect failures. I was involved in a project at MIT. We were using machine learning algorithms to process telemetry data and predict failures. I believe the next logical step is moving those algorithms on board the satellite. Probably the other area is everything related to bringing more value from space to the Earth. And you can do that in two different ways, either increasing the size of the pipe, and there are a lot of people working on technologies like adaptive coding and modulation with probably the most common one being DVB-S2 that was conceived to be used in geo satellites to broadcast information. And now the industry realized that it's good enough to be used to transmit all sorts of data in LEO satellites as well. So that's why, some years ago, we had this big satellite transmitting up to 300 megabits per second in X-band. And today, we are talking about 1 or 2 gigabits per second, like the one that Planet presented in the last small sat of the Japanese Space Agency, more than 2 gigabits per second. It's because of this technology. Also, optical communications. I was in a lab at MIT that were developing optical crosslink, not so focused on speed, on throughput, but more on timing, synchronization between satellites, and also transmitting information to ground. So this is another way to increase the size of the pipe. And finally, I believe that you can also select the information you send to ground. It's not only about increasing the size. For example, there is a lot of machine learning being used to select the images classify the good from the bad ones when you have too many clouds. Or for example, a lot of algorithms trying to implement a lot of algorithms on board the satellite to process information from different instruments. For example, instead of sending all the raw data from a synthetic aperture radar, you can process on board the satellite and downlink the final product, the image that is, in comparison to the raw data, is very small. So again, it's increasing the size of the pipe, selecting the information, and I believe that for all of them, you need smart algorithms and probably the high performance electronics to support that. And maybe that's the connection with Novo Space.
That's great. Thank you, Rodrigo. And just before we move into the Q&A, I just want to ask you, Rodrigo, so what is Space VPX?
Well, Space VPX is a serial backplane standard, which means that it defines the way in which two electronic boards talk to each other through the backplane, through the motherboard. It's very new, it's very powerful because it relies on serial connections, SerDes. So you can transmit more than 10 gigabits per second per line, at least some gigabit per second per line, and there are many lines, many network topologies supported in the backplane, like mesh or dual star, whatever you want. So it's very flexible. The standard leverages the open VPX standard that is widely used in the defense industry, but it adds an extra layer of reliability. For example, there are no single point of failure in a Space VPX subsystem. Even the power rails are point to point. So you can have a failure that is propagating in the system. And yeah, we are developing a lot of technology under that standard. We believe that if you combine that standard with powerful electronics, then there is a lot you can do with one single box. We believe that in the future, these medium-sized satellites are going to be more like 1 or 2 mechanical boxes with electronic boards connected through a high throughput backplane with cross-strapping, and each electronic board is going to be implementing the functionality of a full subsystem today. So you have low swap, low size, weight, and power, but you still have modularity. So you can have a team working in these electronic boards. You can reuse electronic board and the algorithm in the next mission, so on and so forth.
Sounds very powerful. Looks like the future, we hope.
I hope so.
Yeah. So let's turn a bit to the Q&A. You're all welcome to send your Q&As to the button here on below in the Zoom chat. So the first question is, at what point would you consider the industry sufficiently standardized? Once a separate satellite system use common standards, or only once subsystems or subcomponents those systems are made become standardized? So maybe I'll let Andrew challenge that question.
Yeah, sure, I'd be happy to. I think from my point of view, it tends to be the lower sensor levels and component levels where the standardization is important. I mean, recognizing there's multiple different levels of standardization. There's interfaces. There's the buses that that they're on. There's even the power bus that they operate on, whether they're 28 volt, 70 volt, 120 volt. There's a lot of things you can standardize and make common. But a lot of that, I think, is going to start happening at the lower sensor level. I mean, when you think about, from my point of view, there's certain things that most satellites will have, some sort of thruster, standardizing on thruster design, and the valves that they use for those things and the pressure transducers. You'll have solar arrays. If you can standardize, I mean, solar arrays are a little bit hard, but if you can standardize on certain size of solar arrays and what their power capability is. Star trackers are typically, you're going to find those. So having similar star trackers across multiple different buses. Those are the things that I'm seeing, and then getting down into the computers, if you have a computer that's modular and you can swap in and out cards, I mean, standardizing on those types of things. There's always going to be some amount of customization and optimization for the mission, or just for a company to differentiate themselves from their competitors. And you're not going to get, I mean, if you just look at like the automobile sector, cars all kind of look the same. They all have tires, and there's plenty of standards that build an automobile, but, windshields are different, and steering wheels are different sizes, and speaker systems are different. All these things that make them, a unique thing. You're still going to have that in the satellite industry, I suspect. But yeah, the more we can get to being able to get off the shelf pieces and that's where you're going to find it. I don't know that you're ever going to get a whole subsystem, but it certainly seems like it's within the realm of possibility.
Do you agree to that, John?
Yeah, for sure. I think, it's kind of the question the guy posed, two different ways to define standardization. So I'd say the latter. Yeah, when subsystems and subcomponents are standardized, I think that's the target. I think when between different satellites are standardized, that could be like a very future target to enable some interoperability. But I think step one is more the components and subsystems.
I guess, Rodrigo, that's your bread and butter.
Yeah, I mentioned at the beginning that it's basically what Andrew and John said, standardization at component level. When it comes to subsystem level, it requires more tailoring. So I don't know what's going to happen, but for sure it's going to be a combination of standard components in the long term. Yeah.
Thanks. We're almost out of time, but before we wrap up, I really want to ask you, so how do you see the future in 5 years in terms of supplying components, integrating and assembling satellites, or designing satellites? What do you think you'll be doing in 5 years on that part? Maybe I'll let Rodrigo answer since he talked last.
What am I going to be doing in 5 years? I hope I will still be pushing for Novo, and we are going to, and we are developing electronics for many different companies. We don't see the point of these companies that are working in very ambitious goals for them to be working on this, designing the electronics that requires so much background, very long development cycles, so on and so forth. So we hope to become the providers for many of these new space companies.
Thanks. And Andrew, in 20 seconds, what do you think you'll be doing in 5 years if there's modularity?
I mean, me personally, I just hope to keep working on interesting projects. More modularity, I mean, yeah, that just opens up possibilities. Yeah, 20 seconds, so I'll just pass. Give John an opportunity.
I think in the low Earth orbit world, I mean, we really want to see a pivot from bus focus to payload focus, right? The modularity. If we get to truly commodity subsystems and commodity buses, we'll get to some really interesting payload designs. I think that can ride on top of that, because some would argue that the bus problem is solved and buses are commodities, but I don't think that's the case if you're trying to build a mission. So if we can get to the point where buses are commodity and we can really build some really cool and unique payloads across the industry, I think that'd be great.
So just to be able to choose a payload and then the bus goes on top of it and solves all your problems.
Yeah, I mean, the industry is a little bit technology first now, right?
Yeah.
We need to flip that.
That's a great direction. Well, I hope that in 5 years you're all right, and we're all in that kind of direction, and Novo is of course blooming, and we're all just putting payloads directly on commoditized bus with all the different components that we need, buying everything in serial production, modular, and off the shelf. So with that, I'd like to thank everybody for attending. I'd like to thank our panelists, Rodrigo, Andrew, and John. And thank you for all the people that also sent questions. We'll try to answer all the questions later on. Have a good day, and thank you for joining, and hope to see you in the next webinar.
Thank you.
Thank you.
Thank you, Ram.